Morning, good afternoon, everyone, wherever you're joining us from. Welcome to the latest edition of the Lightning Interview Series. As always, we want to make these sessions interesting and interactive, so please do introduce yourself, tell us where you're joining from, and what you do. Now, as you can see, today's interview is with AI expert and author DJ, as we know him, but formerly known as Dipanjan Sarkar. And as you may know, he's very well known in the industry. And our topic is deep learning and transfer learning in NLP. However, before we start, a few quick words about ODSC upcoming events. So continue with our live stream series. On June 9th, we'll be chatting with Lawrence Mooney from Google TensorFlow, the team over there in the West Coast. And the topic, obviously enough, will be on AI and machine learning with TensorFlow. And as always, this session and prior sessions are available on demand in our AI Plus transfer, AI Plus training platform. And those are free to access, by the way. And of course, the main event is ODSC Europe, which will be on June 15th and 16th. That will be, we've got a small in-person audience happening at the London Tobacco Docks. Pretty cool venue, but a lot of our content will be on our virtual platform. And you can still grab a free talk pass. Just go to odsc.com/Europe and look around there. There's a free virtual pass on there. Lots of good talks. We'll be covering MLOps, machine learning, deep learning, NLP, and actually a key track for Europe is machine learning for finance, for those of you interested in quant finance and DiFi and all that good stuff. And by the way, DJ will be giving a half-day training at ODSC Europe virtually. So if you get a chance to join, that would be fantastic. And we do have a pretty generous discount available at the moment. For those of you in the job market, which I know many of you are, we also have our sister website called AI Plus Careers. So it's just like we used to do in the meetup in person. If you're hiring somebody, we'll put your job on there for free. If you're looking for a job, we'll get you job matches. We actually have a very interesting NLP engine and recommendation system running there to help with that process. Maybe we'll get into that in a little bit when we talk further with DJ. All right, and then last but not least, don't forget about, again, AI Plus training. You can click the QR code there. We do have some advanced training on there. So I believe 95% of the content in this platform is free, but we do have things like John Cron Deep Learning Bootcamp is on there. That's a 6-course series. We have machine learning certificates, and we also have foundational series in machine learning and data science covering your favorite topics such as linear algebra and calculus and all that good stuff. All right, but on to the main event of the day. So today's interview is with DJ, or as mentioned, Dipanjan Sarkar. And DJ is very well known in the industry. He's the author of many books on the subject of transfer learning. In particular, transfer learning with Python, also practical machine learning with Python, and text analytics with Python. He either authored or co-authored those, and that's just a few of his books. And we'll be sharing a link with you on that later. He's also the lead data scientist at SIT Academy and a Google developer expert. DJ, welcome to the show.
Hey, thanks for having me here, Seamus. Great to be here again. Yeah.
Excellent. It's a bit early in the morning for me in Boston. I usually do these a little later. So a little slower today than usual, but I'm sure we're going to have an awesome conversation. So DJ, you've had a fascinating journey in data science. And we know each other back from ODSC India in 2018 when we went there in person. We had a fantastic time in Bangalore. But tell us a bit about yourself and your journey to becoming a data scientist.
Absolutely. I won't bore anyone with too many details, but basically I was really interested in understanding how you can leverage insights from data. I actually was learning about software engineering, did my bachelor's in computer science and engineering. And then I really liked some of the topics around artificial intelligence and data mining. I mean, data science wasn't that mainstream then, but I think that was really interesting that those are more of like probabilistic methodologies, right? Not super deterministic always. Like in software engineering, you know exactly what you are building, but this is, you don't know until you build it, how good your model will be. So that is where I kind of branched out into my master's, specializing in data science and software engineering. And then from then on, I started my career as a data scientist in Intel and then kept growing. And right now I'm working as a lead data scientist in SIT Academy Zurich, SIT Schaffhausen Institute of Technology, doing two things actually. One is we help people upskill in data science. That's always been a passion of mine. As you know, I share my knowledge with the community regularly. And the other thing is we work with companies on consulting projects and helping them with their data science initiatives. Yeah.
Excellent. And I think you've been very modest there, DJ. And by the way, everyone, please do post your questions on the chat. Like I said, introduce yourself, tell us where you're from, what you're doing. But of course, if you have any questions for DJ or myself, just please post them there in the chat. And I see lots of activity already. So let's see here. So subject of today's talk is NLP and deep learning. And back, actually, it's interesting what you said about probabilistic methods. Back when I was doing software engineering and rule-based programming and all that good stuff, which I was kind of fascinated with in the finance field, NLP was actually my first introduction to the whole world of data science and machine learning. And back when I started out, you know, a mere 12 years ago, it was bag of words and TF, IDF were all the rage. But tell us a little bit of how NLP has evolved from those, you know, classical methods to the deep learning methods we're looking at today.
Absolutely. I think I started diving really deep into NLP around 2013 or 14, and around 2015, 16 is when I wrote that book, the first edition, Text Analytics with Python. I remember it literally had nothing to do with deep learning then. And then we released the second edition. I would still say it is kind of outdated by now with the rapid advancements we've been having. But I would say, like, we started off with classical NLP, right, which is all about applied linguistics, understanding language and applying more of traditional methods like count-based, frequency-based methods, bag of words, TF-IDF, and trying to leverage some probabilistic methods, machine learning-based methodologies to do some level of predictions or extracting insights using topic models and so on. And I think then around, after a few years, right, we had this new paper, word embeddings, which kind of branched out, and that is where we saw deep learning-based methodologies coming in, where it is not just about frequency-based methods, but about representation learning. Make a model learn representations from text. I think from then on, we have seen an excellent journey in terms of deep learning methodologies, CNN, LSTM, and then finally going into transfer learning, which I think really exploded with the attention is all you need paper. And from then on, we keep hearing about every other maybe month, a new transformer model is coming out and beating the previous benchmark. So it's been a definitely interesting journey where I think we are getting closer and closer to really understanding language as it is supposed to be understood. We are not there yet, I would say. We have not perfected it because every language has its own nuances. I keep talking about this also on LinkedIn, but I think we have progressed tremendously in a short amount of time thanks to deep learning and transfer learning based methodologies.
Yeah, you know, and again, you know, the history of it is fascinating because, yeah, it took me a while to warm up to using deep learning for NLP. And I remember at ODSC, we had quite a few back in, 2017, 2018, we quite a lot of buzz and talks around using RNNs and LSTMs for NLP, and it was mostly about text sequences, right, and all that good stuff, and just parsing your NLP token by token. I still use these basic methods, by the way, for some of the stuff we're doing, like that AI plus career thing we're talking about.
They are still effective. Like, I wouldn't rule them out. Like, it's not like they have become obsolete. Like, when you're starting with the NLP problem, I think I would go with a simple bag of words approach, unless it's something like a translation or a really complex problem where you have to go deep learning. But otherwise, yeah, I mean, I totally agree with you. Like those methods are still pretty effective when needed.
Right, exactly. But you hit the nail on the head, because they all also had, because they were token by token or sequential, they all also had their limitations. So you mentioned Google's paper, "Attention is all you need," and that was 2018 ground. That was a huge milestone in NLP. So for those of us on the call who are not that up on transfer learning, can you give us just a basic intro to what transfer learning is? And then we can get a little deeper into it.
Yeah, in simple terms, transfer learning is leveraging the knowledge you have learned from doing some task in the past into a new task, let's say you're doing in the future. Like, let's say if you know how to ride a bike, it'll be slightly easier for you to learn how to ride maybe a car, something like that, right? If you know, or if you have a solid foundation in statistics or math, it'll be easier for you to learn machine learning. There's a no-brainer. If you know machine learning, you can leverage that knowledge to learn deep learning better, right? So we see transfer learning examples from our day-to-day life, actually, and these are solid examples, right? Because when you learn about machine learning, you learn about concepts like gradient descent, optimization, and literally the exact same things are used in deep learning, just that the models are multi-layer neural networks. So from a technical perspective in transfer learning, typically you have, let's say, a huge amount of data. You build a model which can learn something from that data. Now, what is that something? That something is typically some level of representations, weights in layers, and then you take that and you adapt it to some kind of a new problem. So that is basically transfer learning, which has become effective, especially if you have less data-related problems, data scarcity, and so
on. Excellent answer, DJ. And we're going to back up slightly here because we've got an interesting question from one of our audience. And we were talking about this earlier, like the evolution of NLP from bag of words to TF-IDF, and then co-occurrence matrix, and then word-to-vect was a big breakthrough at its time. And Dipanjan, sorry, I had a question, but people keep posting, so it's moving on me. So Dipanjan Sarkar had a good question, and it just came across your screen there. Do you have any opinions on the future of word embeddings? More specifically, can you see mathematical models such as algebra, etc., being applied in the space of embedding problems? Any thoughts on that?
I would say that embeddings is what is driving literally a lot of applications. Even yesterday, I made a post about similarity-based applications, right? Recommendation systems, image search, building custom search engines, and even natural language understanding. So I think everything starts from embeddings. Typically, an embedding layer is your input to any model, literally. Even in transformer models, you will have embeddings. Without that, nothing will happen. But the only thing what we are seeing now is that word embeddings were traditional in the way that they were a fixed window-sized approach, taking a sliding window and learning those representations. But now it is getting bigger and better, where you have concepts like self-attention from transformer models, contextual embeddings coming in. And I think those are ways in which the concept of how you represent an embedding is getting better and better. And right. I think that is what is going to be continued in future areas also, because at the end of the day, no matter what we do, at least till now, computers only understand numbers. They cannot understand words directly. So I think the way you represent the words as numbers, typically as embeddings, that will keep getting better and better with different methodologies. I'm pretty sure some new things will also come out in the future.
Yeah, exactly. And we see that applied across other topics as well. Like for London, we're doing something like somewhat related, but it could be used for NLP as vector search and stuff like that, and Q&A answer systems. So that's always going to be a key technique. But going back to your earlier comments, DJ, about pre-trained models, transfer learning and pre-trained models exploding on the scene. Why are they so popular?
I think they
generate so much buzz. Sorry.
Yeah, absolutely. I think the main reason why pre-trained models are so popular is because convenience. All it takes for you to use a pre-trained model is just use one line of code and get it ready on your system and you're good to go, right? The open source revolution, I think that is one of the major reasons why they have become so popular. We see these models keep coming out, right? Like GPT-3 And recently we have DALL-E 2 and ImageGen, which got released maybe this or last week from Google. They are not open sourced yet, right? So let's say if you want to use them, you can't, right? You have to wait for a beta access and all that. Now imagine the same thing happening with literally every pre-trained model coming out, right? Then it wouldn't be all the rage out there, right? Because if people can't access them, if there is no convenient way to use them, then practitioners can't really leverage them for their own problems. So I think the open source revolution is what has made it really popular with companies like Hugging Face and so on. And that is where I think because of the open source revolution, we can really access these models easily. And the next best thing is, because often when we are solving our own problems, we may not have a huge amount of data. Training a model from scratch may not give us that level of performance which we need. So that is where taking a model which has already been perfected to a certain extent to learn representations from huge amounts of data, why not use that and leverage it to solve your own problems? So I think that is where we have seen better performing models rather than training them from scratch. Of course, not always, depends on the domain and the problem you're solving, but in many cases it works really well, has worked in computer vision, now in NLP also. So I think those are the main reasons.
Yeah, exactly. And I think when GPT-2 came out, it was close to a couple of million to train that model over millions of features. And now you're seeing models with billions of features. So no idea what it costs to train GPT-3. So therefore, model fine-tuning, which you mentioned, is a very important component of this. So there's different fine-tuning techniques. And again, I'm a bit of an old school NLP person, so I'm not an expert in these. So would love to hear more about how difficult is it to fine-tune? And again, there's different models as we'll get into, but how difficult is to fine-tune these models, and some of your favorites fine-tuning techniques, if you want to touch upon that.
Absolutely. So I think typically the challenge with fine-tuning, especially NLP models, is not really from a technical or a competency perspective. If you spend enough time researching and going through existing implementations, I'm pretty sure anyone can pick them up within a week. The main challenge is with infrastructure, I think.
Yeah.
To be more specific, compute. Because imagine a BERT-based model that is probably 110 million parameters. Now, the challenge is even if you have an expensive GPU like a 16 gigs GPU, that is not cheap, right? I mean, these systems cost definitely, considering, let's say, unless you're working in a company which can buy a bunch of GPUs for you, right? So that is where I think fine-tuning these models, it is definitely heavy on compute. You need to, let's say you're training this BERT-based model. When you're fine-tuning this, there are ways in which you can fine-tune all the layers. There are ways in which you can freeze some of the layers and fine-tune some of the layers closer to the output, known as the deeper layers. And in this way, when you are fine-tuning these models, what happens is you end up being able to train maybe with a batch size of 13 to 15 at the max. You can't go beyond that. You can't train with, let's say, a 64 batch size or 128 batch size, because you're restricted by the compute. So that is where I think you end up with longer training times, and it takes a fair amount of time to fine-tune the model. Of course, if you have a good GPU cluster, you can distribute the training and, of course, fine-tune it faster. But I think that is one of the main challenges. And that is where, interestingly, we have seen this new area of research called model distillation, knowledge distillation, where people are trying to take the exact same model, remove some of the parameters which are not being used that frequently, and compress the information into a new model. And just like distill BERT, which you can train faster and still get, let's say, 95% performance of base BERT.
Yes, I think Seamus will rejoin in a moment. You can go ahead with the questions that is in the chat. there was quite some appeared. So we can start from the below or from the bottom, whatever would work for you.
Sounds good. Sounds good. Yeah, I can see some questions. So, can you suggest some books, courses, other material can be useful to improve knowledge on deep learning? I mean, see, there's a lot of material out there, right? So, what you can do is if you already know basics of natural language processing, then you can, to deepen your knowledge, there are some nice lectures from Stanford and other universities, which are open sourced on their specific pages. Like if you just search deep learning for NLP Stanford, you will find a website with all the links to the video lectures, and they are also open sourced on YouTube. So if you want to gain in-depth knowledge, I would start with some of those courses. If you want to gain practical knowledge, then I would suggest that you start checking out some hands-on examples also. That, okay, I learned about CNNs for NLP. How can I apply it with a problem? You can even check out my GitHub. I have open sourced a lot of content from past conferences and other talks and so on, where you will get literally contents ranging from supervised deep learning to unsupervised, and also like transfer learning. So I think learn about a concept in depth from some of these university-based courses, and then reinforce it with some hands-on. There are some books out there also, transfer learning for NLPs, they're from Manning, and of course, you will also get deep learning for NLP. So the main thing here is that follow a hybrid approach, combine the hands-on with some conceptual knowledge, because if you go too deep into conceptual, you will get bored, right? Because nowadays time is the main thing. So that is the best approach to go about. Follow a structured approach, starting from maybe the Oxford or the Stanford course on NLP, and then keep going from there. Okay, I see another question. Is it practical to deploy BERT kind of transformer models in production for a real-time usage if latency is the main concern? It depends. If the problem you're trying to solve can only be solved by transformers, then you have no other option. If the problem you're trying to solve can be solved by a simpler approach, like let's take an example, named entity recognition. You can solve named entity recognition problems with deep learning models like bidirectional LSTMs, right? So if that model is giving you a good enough performance, it's easier to deploy that. It won't take as much compute as a BERT model usually. So then you go with that. But if your only option is a transformer model, then you will have to go with a transformer model approach. Then yes, you have to deploy it into production. There are ways in which you can kind of improve the latency. There are different ways of doing that. You can try also quantized models. That is one way of improving the performance in terms of compute time, right? Not model performance. You can try out distilled models like distal BERT, which can give you faster training as well as prediction. So yeah, focus on what you're trying to do, and then you can accordingly make a decision.
Thank you a lot, DJ. In addition to that, if we can come back to the one that we already have as well, and to the models, what are the most popular transfer learning models, in your opinion?
The most popular transfer learning models, I think right now, the transformer-based models are all the rage. So we started off with BERT, and then it really expanded, right? We got XLNet, and then from then on, we got Roberta. Google came back with Albert, which kind of beat all the benchmarks. And I think every other month, maybe we keep getting new transformer models. So I think any variant of transformer-based models is all the rage right now. Depends on what you're doing at the end of the day. Again, like let's say if you are focusing on text generation, then autoregressive transformers like the GPT family is your best friend. If you're focusing on things like text classification or named entity recognition and other tasks, then auto-encoding transformers like BERT and the BERT family of models really works out well for you. And if you are going for the true transformer model, which uses both the encoder and the decoder stack, that is basically the sequence-to-sequence kind of transformer models like the T5 from Google, BART from Facebook. You can use them for any sequence-to-sequence problems like translation question answering, text summarization, and so on. So I think these are probably the most popular models, and we keep getting newer models. Like we got the XLM model from Facebook, which is a multilingual model which can represent text in, like, I forget how many languages, but multiple languages. And then the newer areas include like multimodal models like Clip and so on, where you can handle multiple modalities of data like image, text, and so on.
I see. There are actually a lot of as well questions going on about the how and when should one use transfer learning, like optimizations, etc. If you can elaborate on this too.
Absolutely. So I think in terms of transfer learning itself, like, and I keep saying this even when I share knowledge out there, is that transfer learning is not a silver bullet to solve all problems. If you are solving a problem, let's say, which is in a completely different language domain, then you can't expect a BERT model, which has been trained on regular English vocabulary, right from Wikipedia and other sources, to work super well there, even if you even if you fine tune the model. So that is where knowing your domain and your data and your problem is very important. If they are of kind of similar domains or scenarios to a certain extent, then transfer learning can be very effective. What you also need to figure out, I would say, like, start off with simple approaches first. If it's like, you can start with simple classical approaches also. Bag of words, DF-IDF, check out how it works. If you're going for a really complex problem, which has to be solved with deep learning, like language translation, question answering, I would usually go directly to transfer learning, because you already have pre-trained models available, which you can fine-tune with your data, because often you will not have enough data for the model to be effective. I will also end up not just fine-tuning the model, but also check if there are fine-tuned models already available. Sometimes you will get a fine-tuned model which is already, let's say, an expert in question answering. Maybe you can try that out of the box and see how it performs. Maybe you can fine-tune that model. You can get a better performance. This is just like a simple example when you're, let's say, solving a problem in the financial domain. Maybe fine-tuning a FinBERT model, which is a customized fine-tuned model of BERT on finance data, is better than fine-tuning a direct BERT model. So yeah, I would say know your problem and scenario, and then accordingly you can always take a call.
DJ, so thanks for that. Just a little bit of a technical difficulty on my side, but
Ruby, no issues, all good.
Yeah, so again, if there's any questions you guys have for DJ, I saw one there earlier. I'm not quite seeing it now. But let's continue on here. So, DJ, have you already covered the most popular models for transformer?
Yeah, we were just covering the different types of transformer models. So yeah, we just covered that one.
And you mentioned earlier Hugging Face, which again came out, was it 2.5 years ago? That's been amazingly successful. But for people looking to get started in transfer learning, deep learning with NLP, what are some of the best open source tools available out there?
Yeah, I think Hugging Face has really made things very simple for practitioners in NLP, where you can take literally any model in 2 to 3 lines of code and get it going in terms of fine-tuning and leveraging it for your own problem. So I think Hugging Face has a long way to go, and I think it has a very promising future. And the best part is it continuously open sources a lot of things for the community. So I think that is one of my go-to tools. Other than that, I would say like regular deep learning libraries like PyTorch or TensorFlow is what we typically end up using to solve these problems. With TensorFlow 2.x, it has become easier with the Keras API already integrated inside TensorFlow. It has become more Pythonic, just like PyTorch. The other interesting aspect is also you have things like TensorFlow Hub, which has pre-trained models available there too. So you can just use 1 or 2 lines of code, just like universal sentence encoders or sentence embedding models. And I think these are typically the go-to libraries in general for deep learning and transfer learning for NLP.
And DJ, I think we'll just share the link in our chat in a moment, but you very generously open source all the code from your book. So I think that's also a fantastic resource for whether you're just getting started in transfer learning for deep learning or looking for more advanced techniques. So we'll share that link to DJ's GitHub page in a moment. But if you find it yourself there, you can go there and find code to lots of his books. And if you have a chance, do purchase one of his books and support his fantastic work. Now, as mentioned, transfer learning has been a major advance for NLP. What are some of the other recent NLP transfer learning advances in the last year or so that have been significant? If you can talk to that, if you don't mind.
I think we will continue seeing a push for self-supervised learning, because like BERT or even regular word embeddings, that was the first push into self-supervised learning, where build these models on a huge amount of data in a semi-supervised or kind of unsupervised fashion. One of the pre-training tasks in BERT is masked language modeling, as many of you might know, where let's say when Google is training the BERT model on Wikipedia, they will mask random words and then try to make the model predict it. It makes mistakes, it backpropagates the error, and it tries to build better representation. So I think this push towards self-supervised learning will continue, and we will also see more of like multilingual representation learning, just like Facebook open source the XLM model, which supports representing multiple languages. I think maybe over 100 languages, if I'm not mistaken. So I think that is something which is very interesting, because that kind of tries to eliminate the need of having a separate model for each kind of language. If we can achieve that, that will be great. And the last thing which I think we will keep seeing is multimodal learning, where you're combining text with audio, video, and learning representations. Recently, we had DALL-E 2, which was released, well, not open source, but still released. And Image Gen, Google came out with that, I think maybe this or last week, where you write a text like a dog running on the beach in the style of a Van Gogh painting, right? And then it will generate the image for you. So I think generative transfer learning, along with this whole concept of multimodal learning, these things will continue to get bigger.
Yeah, so I'd love to pick up on DALL-E 2, because I see a ton of derivative projects on GitHub around DALL-E 2, and it's one of the hot topics we have for coming up in West Coast, ODSC West later in the year. I don't think we have anyone speaking about it. They'll probably touch upon it at ODSC Europe in a few weeks. So that's that's using text to describe an image, and then generating an image from that, which I think is fascinating. And if you go on to GitHub, there's one project there which shows like avocado on a chair, and sure enough, we can generate an avocado sitting on a chair. So you can do some quite interesting stuff. So can you talk to us a little bit about the models behind that, if you can? That was from OpenAI, right?
Yeah, so basically, I think I was recently checking the Image Gen model from Google, which they claim is better than DALL-E 2. So interestingly, a lot of interesting aspects are going there. One is you're having a text model which is learning the representations from the text itself. Then you're having this concept called as an image diffusion model. I haven't dived into the paper yet, but that is where they are trying to make the model learn representations to generate the right kind of image constructs from those embeddings from the text itself. Then interestingly, they are also applying an image super resolution model, where once the image is generated in a low resolution, they're upscaling it. So looks like around 2 to 3 models are being combined together to generate this crazy thing, right, which is giving us those images. So I think it is definitely where we will see more and more examples of multiple models being combined together, as well as the multimodal aspect of image to text translation, then image to image translation from a low to high resolution, and so on. So I think all of those things are coming into play with these kind of models. Yeah.
No, it's fascinating, and something I'm going to keep a very close eye on. Another quick question from one of our audience members, Naga Mayuri. She says, "Thank you, DJ, for the session. Nice to see you. Is it practical to deploy BERT kind of transformer models in production for real-time use if latency?"
Oh yeah, I think we just covered it before you had gone. We covered it before you had gone off. So yeah, I mean, ultimately it depends on your scenario. If you can't afford to use like if you have to use transformer models, then you have to go with it. Different ways of optimizing it, knowledge distillation and other aspects. So yeah, that is what I would recommend. Yeah.
Excellent. And getting back to, I see a lot of traction with multilanguage models, multilingual. And obviously, as you mentioned, the big problem there is having to train all these models independently. So what are some of the methodologies folks are using to solve that problem?
I think if you're really interested in like a multilingual learning, also known as cross-lingual learning, go out there and check the XLMR research from Facebook, now Meta, that is Meta AI. So that is where you will find that they use concepts related to, like I said, self-supervised learning and this new area known as cross-lingual learning, where model is trained in one languages and then it is used with other languages without any additional training data, as they say in their research paper. And this is where they've also open sourced the code and the model. So that is what I would definitely recommend. And again, they're using similar concepts as transformers, like mass language modeling and so on, just that they are using this cross-lingual aspect of multiple languages and trying to learn the representations in a collective fashion. So
yeah, another fascinating field. And again, one of our audience, Sanjeev Rowe, would love for you to explain more about multimodal learning, which you touched upon just a little bit earlier.
The whole aspect of multimodal learning is where you're leveraging multiple modalities of data like text, images, video together and learning a collective representation, which can help in either translating from one to the other and so on. One of the examples like WAV to VEC is where you're handling, I think, audio data. That was also probably released by Facebook/Meta, if I'm not mistaken. One of the simplest examples of multimodal learning, which you may have done in the past, is just like image captioning, where you're learning the representations from image data, you're learning the representations of your text data from embeddings, and then you're trying to bring both of them together to predict the right words given an image, and you're optimizing the whole network collectively. So I think that is what is multimodal learning in a nutshell, where you are basically taking multiple modality data from multiple modalities and bringing them together in one or multiple model architectures, combining them and optimizing them to get to an objective like image to text translation, text to image translation like CLIP, DALL-E, and so on.
Yeah, and I love doing these interviews, DJ, because just listening to you, I'm learning so much myself in these more advanced NLP techniques. And along those lines, we have a very good question from a LinkedIn user. It doesn't have a name attached to it, but something I haven't even thought about myself, but I think it's an excellent question. Model explainability, model interpretation has been a hot topic for the last 3 or 4 years. And we have LIME, we have SHAP for a classical machine learning. But what are some of the explainability models, interpretation models you're seeing for NLP, if any?
I think there are a few. I had shared one also recently, which kind of helps you into I think it is called LSTM Viz. So there is an open source project on GitHub. You can check that out. That is very useful for sequential models, where it tries to use the hidden state embedding representations, which are ultimately affecting the prediction the most, and it tries to highlight them. So that is one thing you can definitely check out. There are some transformer-based interpretation methodologies also, which have come out, which all they try to do is they try to take the multi-headed self-attention head embeddings, which are being generated, and they try to show you which are the embeddings which are affecting the prediction the most. Again, it is not super intuitive in a way, because inside one transformer model, you have so many attention heads, so it can get pretty crazy. But that is the best we have at this moment in terms of trying to unbox these really complex models. So those are the ones I would recommend. You also have SHAP-based models for LSTM and other models, if I'm not mistaken, because I've used them in the past. Are they reliable? I would say to a certain extent, because see, at the end of the day, these are complex nonlinear models, and all these interpretation methods try to do is try to look for signals from backpropagation. That is one thing. The other thing is it is known as like a locally accurate model. It will take a prediction which you're trying to explain. It'll take a neighborhood around that, and then it will try to generate the explanation. Does that mean it is for the model as a universal, what it has learned universally? Not really. So that is where you will constantly even keep getting these arguments that SHAP is not learning the same thing as if you try SHAP on linear regression. It won't, because it is learning things based on local approximation, but that is the best you can get when you are trying to unbox these really complex models. So these are the things I would recommend.
Excellent. And another question we have from one of our audience members is, what's the best way to get started with NLP? Any books, resources, courses you could recommend? So before you answer that question, DJ, I would definitely recommend DJ's books. As you can tell, he's an excellent instructor, a storyteller extraordinaire. And DJ has a whole series of books on there. And as mentioned, Deepti has already shared the link to his GitHub repositories and code bases there. But DJ, any other courses?
Yeah, I think, I briefly mentioned this, but if you want to start it, like go with a university open source course, like from Stanford or Oxford, you will get a lot of those CX, whatever, 2XX, XX being the number and so on. So you will get those web pages where they open source the lectures. Go through those lectures, but follow some hands-on. Like Seamus mentioned, I've open sourced a lot of that online, and you can definitely get it from my GitHub, and you can try out those things. So yeah, combine course-based learning with a hands-on learning where you are actually implementing those models, because at the end of the day, you are usually training to be a practitioner. So that is what will help you.
Exactly. And we are coming to the end of our 45 minutes. And I apologize if we couldn't get to everyone's questions. It was a very interactive session. DJ, just to wrap it up, what's next for you? I know you're a bit of a data science rock star, so you're going to be attending, instructing virtually at ODSC Europe in a few short weeks. What's next project-wise? Any books or other projects in the near or long-term future?
I'm planning to get back to writing, which has been off for a while. People keep reaching out to me that you've written some amazing articles, but yeah, like last year I took a bit of a break. But yeah, you can definitely expect more content from me in terms of different aspects of machine learning, deep learning, transfer learning, NLP, computer vision. I will cover some interesting areas like image super resolution itself, and definitely areas around NLP transformers. So yeah, expect more content out there. I will share it also on LinkedIn. We'll write up some articles also. So yeah, those are things which I keep doing as a part of my passion. Other than that, I think we keep doing a regular stuff in terms of helping people upskill in data science, getting the best knowledge from a hands-on perspective also, because most of the people we help are doing things to ultimately go into the industry usually. So that is one thing which continues. And other than that, consulting projects around NLP, computer vision, deep learning, machine learning. Interestingly, machine learning based projects are still, I would say, not out of fashion. While this is a deep learning talk, I would just want to reiterate that, don't run behind the hype of deep learning. There are a lot of problems even in NLP, like let's say you're doing a simple classification problem. I will guarantee you a bag of words plus a linear SVM model may give you, or even a bag of words plus a logistic regression model may give you a much better performance than a deep learning model. This has happened several times. So it depends on the nature of the problem you're solving, the domain, and so on. Of course, deep learning and transfer learning are the go-to for any complex problems, but let's take clustering, let's take classification, and so on. Often, or even topic models for that. You have now models leveraging BERT embeddings and so on. You have frameworks like contextual topic models, BERT topic, and so on. But even simple latent Dirichlet allocation, right, based on probabilistic methodologies that can give you really good topic models. So that's what I will say, like try out simple and then go complex. And that will help you basically solve the problem in the most effective way possible.
Yeah. And actually, you're jogging my memory, DJ, because, people hear that start simple, start small, go to complex. But I actually have a bit of a user journey I can share with the audience that I can credit you with, because we were running career fairs for ODSC back. We started doing career fairs in 2016. And we saw we were repeating a lot of the same stuff. We were doing career lab. We're advising people, what they should put on their resume for a data science role or a deep learning role and all that stuff. And I remember you'd mentioned back in one of your previous positions, you had done some resume parsing and all that stuff. And as mentioned at the top of this interview, we built this platform. It was one of my pandemic projects. And we built this platform called AI Plus Careers, which is basically a recommendation system. It'll take your resume and match you to jobs. So essentially, it was a big parsing job, parsing job descriptions on one side, parsing resumes on the other side, using some pretty basic models. And just like you said, because I remember asking your advice, and you told me keep it simple, because I was thinking, reading a lot of papers about deep learning models across resumes, and they weren't working very well because they were very generally trained. Even these pre-trained models don't work well. So if you guys want to try out the AI Plus Careers and see how your resume is parsed and all that kind of stuff, because a lot of resumes these days go through what they call the application tracking system, and those systems are looking for keywords, and they're doing entity recognition, and entity recognition across companies is still a very complex problem. People are doing pairwise matching and fuzzy logic and all that stuff. But I do owe credit to you, DJ, back in, I think it was ODSC India 2018, as that project was percolating in my mind, and in 2020 I finally got to execute it. So yeah, and I've listened to DJ, learned a lot from him over the years from just listening to his talks. So I would encourage you to go to his LinkedIn profile, follow him, and keep an eye out in those articles, because you'll be all the more very much up to speed with the advanced in NLP and some of the very interesting work he's doing. And again, DJ is a fantastic instructor. I think you can take courses at his institute there. Are also in a couple of weeks at ODSC Europe. He'll be doing a virtual session. Did you cover that virtual session, the NLP session you'll be doing at ODSC Europe, DJ, by any chance?
Not much, really. So yeah, those of you who are interested, we are doing like a half-day training on deep learning and transfer learning for NLP. It will be completely hands-on. We'll definitely have some slides so that you get some basic concepts like word embeddings, transformers to an extent, and so on, for those of you who may not know. But it'll be fully hands-on, where we'll go through a bunch of notebooks. We'll actually start off simple deep learning methods like convolution neural networks. Especially CNNs are often effective for NLP, unlike some people think only computer vision. So we'll cover CNNs for NLP, LSTMs for NLP, and then we will go into more complex aspects like bidirectional LSTMs, and definitely transfer learning, where it will be all about understanding not just transformers, but also how you can use pre-trained word embeddings, pre-trained sentence embedding models. And then we'll go into transformers, cover different aspects of transformers, how you can easily take pre-trained transformer models, use them out of the box for a variety of tasks, and also how you can fine-tune transformer models. So we'll look at, of course, the Hugging Face framework. We'll even look at some of the frameworks I've shared in LinkedIn in the past, like simple transformers, which you can literally use and within a few lines of code get it going for problems like question answering, NER, classification, and so on. So yeah, definitely a lot of hands-on is planned. And those of you who are interested, like those of you maybe who are having an interest in starting out but are not getting the motivation to maybe getting kick-started, if you attend this session, you will be bombarded with so many things that you will get that motivation to expand on each notebook and start learning right away, because that is what has happened with the people who have attended the past session. So yeah.
Awesome. Yeah, we're really looking forward to that, DJ. And once again, thank you so much for being such a good sport, coming on this show. Always a pleasure to see you. Always a pleasure to listen to your great insights. And DJ, we'll see you in a couple of weeks, and hopefully in person one of these days. But thank you so much again.
Absolutely. Yeah, no problem. Thanks a lot, Seamus. Thanks a lot, everyone. Take care.
Thank you to our audience, and tune in a couple of weeks. We'll have a session with Lawrence Mooney from Google. Thanks now, everyone. Bye-bye.